let's go through some activities. So this example here shows us the how to determine the network address, and in that case we need to write the network address in binary. And this is a very easy example, because what we could do is that see the subnet mask, and the subnet mask here has only one bit borrowed from the last byte. So this means that this bit will be set from the network address directly, or the host address, and the rest will be zero. So this will be simply this same binary will be until this bit it will be put here, and the rest will be zero. So we can simply do that by doing this. And then for this byte, this bit will remain the same, and the rest will be zeros regardless. So 0 and then 7 zeros. So simply this is in decimal, which is the same number, this same host address, until this number, which will be set to 0 in that case. So 192.168.71.0 in that case. So hopefully this is correct. Okay, so correct. All right, so we can try a new number here. So remember, here we have also one bit borrowed, which will make this 1 and all zeros, and this is 128, so that number is easy. So let's see. Yeah, so this example here shows 5 different bits, which means that all these 5 bits will remain the same, and the rest will be 0. So also this will be 56. So that's also a simple example. So let's take another. Yeah. So this number, for example. So the host address is 173 in the last byte, and the subnet mask has 4 ones, which means that all these 4 bits will be set to zeros in that case. So let's see how this number will look like. So again, we will set the same number here, and here it's 10101000 and 0110001, and let's see this number, so 1010, and the rest will be zeros. So this number is actually 128 plus 32. So if we have 128 plus 32, that's 061. Okay, so this is 160. So we go back here and we put 160, and the rest will be the same. Okay, so let's see if that's correct. All right, so correct. All right, so the next activity is just to calculate the number of valid hosts, and of course, the number of valid hosts is just to take the number of bits for the host portion, which is in that case 5, and then 2 to the power 5 minus 2. 2 to the power 5 is 32, minus 2, that's 30. Right, and all right. So that's another example. So again, here we have only 3 bits, so it's 3 bits, 2 to the power 3 minus 2, which is 6, new number. Here we have only 1, so we have 7 bits for host, and 2 to the power 7 is 128, minus 2 is 126. Alright. Okay. So let's move to another activity. So this activity is a little bit complex. So what we need to do here is that we need to calculate the first usable host address given this network address and the subnet mask. And the network address, this is the network address in binary, just to simplify the exercise for you. So as we said before, the network address in decimal, so this is the network address in decimal. So the first usable host will be simply 192.168.46, and then remember here in this byte, we will keep the network portion or the subnetwork number as is, and then the rest will be all zeros and then 1. So this is 0, 1, 1, 0. and then 0, 0, 0, 1. So this will give us, this is 64, 32 plus 1. So 64, 32 plus 1. So this is 7, 9. So this will be 97. Okay. The last usable address will be, again, to set 192.168.46 as is, and then we will set the last portion here to 0, 1, 1, 0, and then 1, 1, 1, 0. Okay, so we'll convert this into decimal. So again, this is 64 plus 32, and this number is actually this number is 14. So 64, 4, 2, 0, 61, this is 10, this is so this will be 110. The broadcast address is simply to increment 1 here. Okay, so it's 192, 168, 46, and then we increment this by 1. So 1, 1, 1. So the next network address or sub-network address will be to increment the broadcast address by 1. 168.46.112. Okay, so let's see if that's correct. Correct. All right. So so that's how we convert or calculate the first and last usable host addresses. We move to the last activity here, which is to calculate the subnet mask in binary. So we can calculate the subnet mask in binary. This is 111111, then 11111, and then the last, as we said before, 192 is 11, and then the rest will be zeros. And of course, the prefix portion would be to borrow 2 bits from the last. So these are 24, so we borrow 2 bits, so this makes it 26. Another example, so this example is also easy, so 111111, and then ones, and then this is 110000, and then the rest will be zeros. Okay, so this is, remember, this is borrowing 2 bits from the third one. So these are 16 and 2, this makes it /18, and so on.